Hi everyone, welcome back to Beginning Algebra. Today we're in section 1.1, which is titled Exponents, Order of Operations, and Inequality. Here are the objectives we're going to work on today. I'll show you how to use exponents, how to use the rules for order of operations, how to do order of operations problems that have more than one grouping symbol like brackets and parentheses. We'll talk about the meanings of all the different inequality symbols. We will practice translating word statements into symbols, and then we'll practice writing statements that change the direction of inequality. There's lots of good foundational information in this section, so I hope you'll take your time and work through it carefully and really think about it, and don't try to memorize your way through it, but really try to think about it and understand it. And if you do that, then this section will be very valuable to you. Here we go. Now first, let's glance backwards just a little bit. Remember that in the last section we learned how to find the prime factorization of a number like 40, and we would have said something like, well, 40 is 4 times 10, and 4 is 2 times 2, and 10 is 2 times 5. So we would have said 40 is 2 times 2 times 2 times 5. Well, you can imagine the more times you have a single factor repeated, the more of a pain it becomes to write down that factoring. So we would like to have a shortcut way to say this factor is repeated this many times. And that's what exponents do. Instead of writing the repeated factors over and over, we can just use exponents. Now an exponent is also called a power, and it tells how many times the base is used as a factor. So for example, we could write 40 equals 5 times 2 times 2 times 2 as 40 equals 5 times 2 to the third power. And notice that our exponent is in superscript. So now here's the way it goes. The number that is in large type, that is the factor that's being repeated, that number is called the base. And the exponent, which is in superscript type, is the number that tells how many times that factor gets repeated. So 2 times 2 times 2 would be read as 2 to the third power. Now let me give you a couple of terminology shortcuts. A lot of times, instead of saying to the second power, we just say squared. They mean the same thing. To the second power means squared. And likewise, we use the word cubed to mean to the third power. Now the way that this came about is linked to geometry. For example, if you had a square and the sides were length s, then the area of this square would be s times s, which would be written as s to the second power. So you can see it makes sense to talk about the second power as being squared. And the same kind of thing happened with the third power, except a cube has 3 dimensions. So if you wanted to calculate the volume of a cube, you'd do its length times its width times its height, which in this case would be s times s times s, so s to the third power. And you can see how the third power became associated with the word cubed. And again, the second power became associated with the word squared. Now let's practice finding the value of each exponential expression. So what I'm going to do first is write it out in multiplication form, and then we'll evaluate. So 5 squared, or 5 to the second power, would be written as 5 times 5. See how we write it in multiplication form. And then we know that 5 times 5 is 25. Now when you get into MyLabs Plus, you may or may not have to do this middle step. You need to read the instructions on each problem to see if they want you to write it in multiplication form or just evaluate. Okay, let's look at part B. 6 to the third power in multiplication form would be 6 times 6 times 6. And now to evaluate this, we know that 6 times 6 is 36, and then we need to do 36 times this next 6. And if you don't know that off the top of your head, you can come over here and jot it down and work it out yourself, and you see that 6 times 6 times 6 is 216. Now let's look at part C. 2 to the fifth power would be 2 times 2 times 2 times 2 times 2. Okay, let's just go through this together. 2 times 2 is 4, times the next 2 makes 8, times the next 2 makes 16, and times the last 2 makes 32. So 2 to the 5th power is 32. And then on part D we have 2/3 to the 3rd power. Now don't freak out just because it's a fraction. You know what the 3rd power means. So we're just going to write down that 2/3 to the 3rd power means 2/3 times 2/3 times 2/3. Now we know that to multiply fractions together, we multiply tops and then we multiply bottoms. So in the top, 2 times 2 is 4 times this next 2 makes 8. And in the denominator, 3 times 3 is 9 times this next 3 makes 27. So 2/3 cubed turns out to be 8/27. Now, it's a common mistake for students to get exponents confused with multiplication. Remember, an exponent is not the same as multiplication. For example, 7 to the 2nd power does not mean 7 times 2, but it's a very common mistake for people to write that 7 to the 2nd power equals 14. Of course, it doesn't. 7 to the 2nd power means 7 times 7, which we know is 49. So you need to make a clear distinction in your mind between exponents and multiplication. 7 to the 2nd is 49, but of course 7 times 2 is 14. Now we're going to move on and talk about order of operations, and this is a very important foundational concept that you will use on every problem you work in algebra. As long as you're working on math, you have to follow the rules of order of operations, just like as long as you're driving on a road, you have to follow the traffic rules. The traffic rules never go away as long as you're on the road, and order of operations never goes away as long as we're working on math. So all mathematical expressions contain the following operations. They're all made of exponents, multiplication, division, addition, and subtraction. And then some expressions contain grouping symbols like parentheses and brackets. Now, math is a written language, and an expression needs to mean the same thing to all the different people who read it. So we have to have rules about which order the operations should be done in. For example, take a very simple expression like this one, 5 plus 2 times 3. One person might look at this and say, oh, well, I think we should do the addition first because it comes first in order from left to right. So they might say 5 plus 2 comes first, and then 5 plus 2 is 7, and then 7 times 3 is 21. And another person might come along and say, no, I think we ought to do multiplication first because it's more important. Well, then that person would do 2 times 3 first, and 5 plus 2 times 3 would become 5 plus 6, which is 11. Now, they can't both be right, so one of these ways has to be considered right and the other considered wrong. So let me give you the correct order that the steps should be done in. This is what we call the order of operations. You may have also heard it called PEMDAS, which is actually the acronym for the order that the steps should be done in. Or way back in middle school, you might have learned, please excuse my dear Aunt Sally. Well, we need to talk about that a little bit because you just can't go from left to right here. Let's see how it works. So what we're going to do is perform all the operations that are inside any grouping symbols first. Now, by grouping symbols, we mean parentheses or brackets. And this is the order we're going to go in. First, we apply any exponents. Then we do all multiplying and dividing in order from left to right. Then we do all adding and subtracting in order from left to right. Now, if there are no grouping symbols present, then you'll just go through these steps from here. If there are grouping symbols present, do these steps inside the parentheses and then do these steps again until you get it all worked down to one number. So let's talk about this acronym a little bit. Now, P stands for parentheses, but it also could mean any other grouping symbols like brackets. So first, work anything that's inside a grouping symbol. Then E stands for exponents. Then we do any multiplying and dividing in order from left to right. So it's very possible now that division could come first. It depends on the order from left to right. And then we do any adding and subtracting that we have in order from left to right. So again, first we do any operations that are inside grouping symbols, and we do them in this order. Exponents first, multiplying and dividing in order from left to right, adding and subtracting in order from left to right. And once we've worked out all of the grouping symbols, then we go through and apply these steps again until we've worked down to a single answer. Now we said work inside the parentheses first, but sometimes there's only one number inside the parentheses, and in that case there's nothing really to do in there. And the reason you might see that written that way sometimes is because, remember, parentheses can be used as a multiplication symbol. So parentheses 7 parentheses 3 also just means 7 times 3. So parentheses 7 parentheses 3 equals 21. So on a problem like this one where we have 3 parentheses 4 plus 1, first we would perform the addition that's inside the parentheses. So this would become 3 parentheses 5. And then we would recognize this is multiplication. So we would say 3 times 5 equals 15. Now here's our next example. Let's use our new rules for order of operations on each of these expressions. So what I want you to do, and especially when you're showing your work in MyLabs Plus, is underline the step that you're about to do, and then on the next line show the result of that. So looking at a problem like 24 minus 12 divided by 3. First I have to decide whether I'm going to do subtraction or division first. So I remember PEMDAS says multiplication and division come first, and then addition and subtraction. So I decide to do this division first. I'm going to underline it, and now I know that 12 divided by 3 is 4. So on the next line, I'll write 24 minus 4. And then we can just do the subtraction. 24 minus 4 is 20. So this is the way your work should look when you're working on order of operations problems. Underline the step you're going to do, and then show the result of that, and then just work your way down to the answer that way. I know our show work policy says not to use the pencil tool to write numbers, but you can use the pencil tool for underlining, so that will be fine. Type out your expression and then underline what you're going to do and then do it. Okay, let's look at part B here. So I have 9 times 6 plus 11 in parentheses. And of course, order of operations, PEMDAS tells us work what's in the parentheses first. So first I'll underline my 6 plus 11, and I know 6 plus 11 is 17. So now I have 9 parentheses 17. Of course, if you'd rather write your multiplication as 9.17, that would be just fine as well. The parentheses really aren't necessary anymore. But if we're not going to use the parentheses, we need to use something to show multiplication. So here we have 9 times 17. So you can either work this out mentally, or if you need to jot it down to work it, that would be fine. I want to encourage you not to reach for a calculator, because you need to practice working this out yourself, because on your proctored tests, you will not have access to a calculator. So if we jot it down and work it out, we see that 9 times 17 is 153. Now, I don't know if you've noticed this yet, but order of operations problems can look all different ways. So I think the more examples you see and the more examples you work through, the better off you are. I've got a couple more examples for us here. In part C of example 2, we have 6 times 8 plus 5 times 2. Now, this multiplication is not affected by this second multiplication, because notice they're separated by this plus sign. So I'm going to go ahead and underline both multiplications. In this case, because they don't affect each other, we can do them both in the same step. So 6 times 8 is 48, plus 5 times 2 is 10. Okay, now there's only one operation left, and of course 48 plus 10 is 58. And now let's look at part D. Here we have 48 divided by 2 times 3. Now, a lot of people's first knee-jerk reaction is they want to do 2 times 3 first, because they're thinking about PEMDAS and all they're thinking is that M comes before D. That would be wrong. Remember, we said we do multiplication and division in order from left to right. Multiplication and division are equal in rank. So we'll actually need to do this division first. So I underline the division. 48 divided by 2 is 24. And then I have 24 times 3. And if you can't work that out mentally, you might just jot it down. 24 times 3 works out to 72. Now I want to make sure and emphasize this point again because this is a large pitfall for a lot of folks. Remember, multiplication does not necessarily come before division just because M comes before D in our acronym. Multiplication and division are of equal importance, so they are done in order from left to right. Multiplication and division are of equal importance, so they are done in order from left to right. So let's look at a problem like this, which is similar to the last one we just did. If you were to think, well, M comes before D, so I'm going to do the multiplication first, you'd have 24 divided by 6, and we know 24 divided by 6 is 4. But this is not correct. Again, on a problem like this, when all you've got is multiplication and division, you have to do them in order from left to right. So 24 divided by 3 is 8, and 8 times 2 is 16. And this would be the correct answer for this problem. Okay, now let's practice just a little more with our rules for order of operations. Here we have 16 minus 3 times 2 plus 3. So remember your acronym, PEMDAS. So first we need to do any operations that are inside grouping symbols, and here I see a grouping symbol, our parentheses, or what we mean by grouping symbol. So I'm going to underline the 2 plus 3 and do that first. 2 plus 3 is 5. So on the next line I'll have 16 minus 3 times 5. And again, if you don't want to use the parentheses as your multiplication symbol, you could say 3.5 here. Okay, so we have 16 minus 3 times 5. Between subtraction and multiplication, definitely multiplication has to come first. So 3 times 5 is 15, and then we can do our subtraction. 16 minus 15 is 1. And let's look at part F. Here we have 2 times 5 plus 5 plus 7 times 3. So again, going to our acronym, we know we have to work any operations inside parentheses first. So 5 plus 5 is 10. Now I have 2 times 10 plus 7 times 3. These two multiplications do not affect each other. They are separated by a plus sign. So I'm going to do both of them in the same step. 2 times 10 is 20 plus 7 times 3 is 21. And then we can do our addition. 20 plus 21 is 41. And here on part G we have 9 plus 2 to the third power minus 5. Okay, we don't have any grouping symbols here, but we do have an exponent, so that needs to be taken care of first. 2 to the third power is 2 times 2 times 2. It's not 2 times 3, remember. 2 to the third power is 2 times 2 times 2. Now 2 times 2 is 4 times the third 2 makes 8. So now we have 9 plus 8 minus 5. And addition and subtraction are done in order from left to right. So first I'll do the addition. 9 plus 8 is 17. And then 17 minus 5 is 12. And again, this is how your work should look on order of operations problems. Your instructor should be able to follow your work all the way down to the final step. And on any lines where there are two different operations, you want to underline the one that you're going to do. This is how we want you to show your work on these problems. Okay, now let's move ahead to the next objective, which is how to use more than one grouping symbol. If we need to show that one group of operations is inside another group, then what we do is we use brackets for the outside grouping symbol, and that's just to keep the two sets from getting mixed up. So to rewrite this one with brackets, we would say 2 bracket 8 plus 3 times 6 plus 5, and then this last parentheses would be a square bracket. So you see how when we write it this way, it's easy to tell that these two parentheses belong together and these two brackets belong together, and you won't accidentally get the two mixed up because they're different shapes. Now, when you do have two different sets of grouping symbols like this, what you want to do is always start working your problem from the most inner set of grouping symbols, but we will still follow the same PEMDAS order that we've been following. It's just now we'll start at the innermost set of grouping symbols and work our way out. Now keep in mind that a fraction bar can also take the place of a grouping symbol. For example, a problem like this where we have 7 times 8 minus 3 divided by 2 to the third. Since this whole expression is being divided by 2 to the third, you might see it written in fraction form, where the 7 times 8 minus 3 is the numerator, and then it's all divided by 2 to the third power. So remember that this symbol, when you read this and you say divided by, that can always be replaced by a fraction bar. And even though you may not realize it right now, this fraction bar method of writing things is actually easier to comprehend and easier to communicate, and in the long run it's easier to use than this old division symbol. And all that's happening here is that the fraction bar groups the numerator and the denominator separately. So you see now how the fraction bar acts kind of like its own grouping symbol. Now whenever you do have operations in a fraction like we saw in the last slide, what you'll want to do is work the top and the bottom separately and then put the two answers together at the end and simplify if possible, and just leave your answer in simplified fraction form. You'll see this in just a minute on an upcoming example. So now here's example 3, and we want to find the value of each expression still using our PEMDAS order of operations rules. So on this first example, we see 2 bracket 8 plus 3 parentheses 6 plus 5, close the parentheses, close the bracket. And remember, we always want to start with our innermost set of grouping symbols and work from there. So starting with this inside set of parentheses, the only thing to do in there is to add. So we will underline our 6 plus 5, and 6 plus 5 of course is 11. So now I'm going to have 2 bracket 8 plus 3 times 11. And now, still working inside the brackets, my choices are to either add first or multiply first. Of course, we know multiplication and division come before addition and subtraction. So we will underline 3 times 11, and 3 times 11 is 33. So now I have 2 bracket 8 plus 33. Now at this point, because there are no more parentheses, if you prefer to go to parentheses at this point, you are welcome to, because the only reason to have brackets and parentheses is to tell them apart from each other. If all you have is one set of grouping symbols, it can be any kind of grouping symbol that you want. So you might want parentheses here, it's totally up to you. But the next thing to do is to complete the addition inside these brackets. So we're going to underline 8 plus 33. 8 plus 33 is 41, so now we have 2 times 41, which of course is 82. And now let's look at our first fraction bar problem. So remember I told you you could work the top expression separately from the bottom expression, and that's exactly what I'm going to do here. I'm going to separate the top from the bottom, and working on the top first, I see that I'm going to have to work the addition inside these parentheses. 5 plus 3 is 8, so now I have 4 times 8 plus 3. Do the multiplication first, and that will give us 32 plus 3, which is 35. And then for the bottom, it's much simpler. We have 3 times 2 minus 1. We'll need to do the multiplication first. That would give us 6 minus 1, which is 5. And now, putting everything together, our numerator divided by denominator works out to 35 divided by 5, which of course simplifies to 7. Here are a couple of similar problems that I would encourage you to pause the video and try by yourself. Order of operations takes lots of practice to gain the skill that you need, So just listening to me go through the problems is definitely not enough. You need to work some on your own. So now, assuming that you've paused the video and tried these on your own, let's go through them together. On part A, we'll need to work inside the innermost pair of parentheses first. In here, 4 plus 8 is 12. So that's going to give us 9 times 12 minus 3. We know 12 minus 3 is 9. And so now we have 9 times 9, which is 81. And on part B, again, we have a top and a bottom, so let's do those separately. The top is 2 times 7 plus 8 plus 2. Work inside the parentheses first. 7 plus 8 is 15. So we'll have 2 times 15 plus 2. Then 2 times 15 is 30, and we have 30 plus 2, which is 32. And on the bottom, we have 3 times 5 plus 1. Of course, we'll need to do the multiplication first. So that's going to be 15 plus 1, and 15 plus 1 is 16. And now let's put this together. The top over the bottom would be 32 divided by 16, which simplifies to 2 in this case. Now let's take a look at all of these different symbols. Each of these symbols is a symbol of inequality. This means that the two expressions on the left and the right side of the symbol may not be equal. And we say may not because two of these symbols do allow for equality. So now, going through these one by one, this symbol means not equal. The equal mark with a line through it means not equal. This symbol which points to the left means less than. The symbol which points to the right means greater than. The less than symbol with a line under it means less than or equal to. And the greater than symbol with the line under it means greater than or equal to. Now, some people have trouble keeping their symbols straight, so to help you keep the less than and the greater than symbols straight, remember that the small end points to the smaller number and the big end opens toward the bigger number. Your elementary school teacher may have used the analogy with you that the alligator's mouth eats the bigger number, and that still works. So the bigger end of the symbol opens toward the bigger number. Reading from left to right, if you come to the small end of the symbol first, you're going to say less than. And if you come to the big end of the symbol first, you're going to say greater than. Okay, now for example 4, we're going to determine whether each of these statements is true or false. So this one says 6 is not equal to 5 plus 1. Well, we know that 5 plus 1 is 6. So basically what this is saying is that 6 is not equal to 6. Well, that's nonsense. Of course 6 is equal to 6. So this statement is false. Now let's look at part B. Here we have 5 plus 3 is less than 19. Well, we know that 5 plus 3 is 8. So what we have is a statement that says 8 is less than 19. Of course, that is true. And in part C, we have 15 is less than or equal to 20 times 2. Well, we know that 20 times 2 is 40. So our statement now says 15 is less than or equal to 40. Of course, that is also true. In part D, we have a statement that says 25 is greater than or equal to 30. That is not true. That is false. And in part E, we have a statement that says 12 is greater than or equal to 12. Of course, the left side is equal to the right side, so this inequality is actually true. 12 is greater than or equal to 12. So that's true. And then for part F, we have 6/15 is greater than or equal to 2/3. Now it's hard to tell with fractions which one's larger than the other when their denominators are different. But if we get common denominators, we'll be able to tell by the numerators which fraction is larger. So I noticed that 3 goes into 15. That means I'm going to be able to use 15 as a common denominator. To change thirds into 15ths, I'll need to multiply by 5 over 5. And so now I have a statement that says 6 over 15 is greater than or equal to 2 times 5 is 10 over 15. So, is 6/15 greater than or equal to 10/15? No, if the pieces are the same size, then 6 is less than 10, and so we can say that that statement is false. Now for objective 5, let's practice translating word statements into symbols. What we'll do here is we'll just read the statement and then we will write down what it says in mathematical notation. So this says 12 is equal to 10 plus 2. Of course, 12 is equal to, we'll use an equal mark, 10 plus 2. And that's all there is to it. Just read it and then write down what you read. 9 is less than 10. So of course 9 is less than 10. That's all there is to it. We put a less than symbol there. 15 is not equal to 18. So 15 is not equal to 18. In part D, we have 7 is greater than 4. So 7 is greater than 4. That's all there is to it. 13 is less than or equal to 40. So 13 is less than or equal to 40. 6 is greater than or equal to 6. 6 is greater than or equal to 6. And for our last objective in this section, let's practice writing statements that change the direction of inequality. Now, any greater than statement can be rewritten in a form so that it is a less than statement. And also, any less than statement can be rewritten so that it is a greater than statement. We do this in English all the time. Think about the sentence, I am older than Joe. If you wanted to start the sentence with Joe, then you could turn this around and instead of saying I am older than Joe, you could say Joe is younger than I am. So this sentence uses the word older and this sentence uses the word younger, but both sentences convey the same idea. And we can do the same thing with inequalities. So 6 is less than 10 also means that 10 is more than 6. And if we write that in mathematical symbols, then instead of saying 6 is less than 10, we can rewrite that as 10 is greater than 6. We can do that with any inequalities. So let's practice here. Instead of saying 5 is greater than 2, let's restate this with a less than symbol. If 5 is more than 2, that means 2 is less than 5. Now these are easy to keep straight because the pointy end of the symbol is going to keep pointing toward the same number because we don't want to change the meaning of the statement. We just want to change the way it's said. Notice that here we started with the big end opening toward the 5, and when we finish, the big end is still opening toward the 5. So they say the same thing. In part B, we have 1/2 is less than or equal to 3/4. Well, that can be restated as 3/4 is greater than or equal to 1/2. And both sentences say the same thing because the larger end opens toward the same number in both cases. Here are a couple for you to practice on. Here we have 3 is greater than 1. So of course, if we want to use a less than symbol, we'll say 1 is less than 3. And here we have 2/3 is greater than or equal to 3/5. So if we want to change that to less than or equal to, we'll just say 3/5 is less than or equal to 2/3. And that's all there is to this objective. Now if it seems like we did a couple of objectives that really weren't that big of a leap, we did. Algebra isn't always hard, it isn't always difficult. If you'll think about what you're doing, it's actually very straightforward and logical. And so this is going to build your logical thinking skills and get you good at mathematics at the same time. So really dig into these introductory sections and think about them, and then this is going to serve you well all through the rest of your algebra curriculum.